السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. أرحب فيكم في الجزء الحادي عشر من هذه الهيكلة الخاصة باختبار الفصل الدراسي الأول 2023-2024 الصف الحادي عشر متقدم حسب هيكلة اختبار مادة الفيزياء المرسل من قبل مؤسسة الإمارات للتعليم. نتابع اليوم أو هذا الفيديو في الهدف الثامن عشر. لم ننهي الحصة الماضية أو الفيديو الماضي. وصلنا إلى سؤال 62. An airplane starts from rest. We agreed that from rest means VI equals 0 and accelerates at the acceleration A is 12.1 meter per second square. What is its speed at the end of 500 meter runway? This is delta x. Now our equations are V final equals V initial plus AT, V final squared equals V initial squared plus 2A delta x, and delta x equals V initial T plus 1/2 AT squared. And our beloved equation that doesn't contain the acceleration is V initial V final times T. Choose the suitable one. I have V initial and the acceleration and delta x. So I have V initial, acceleration, delta x, acceleration, V initial, acceleration, delta x, V initial. Choose the equation with only one unknown, which is this one, and it's suitable for this question. V final squared equals V initial squared plus 2A delta x. V initial is 0, 2, the acceleration is 12.1, delta x is 500. So the answer is 12,100. Don't forget this is the final squared, V final squared. I need V final. It should be square root of this number. Then the answer is plus or minus 110 meter per second. As our assumption in the question, the acceleration is positive from rest, so I will choose the positive sign. So V final plus 110 meter per second. Now question 263. A boy is riding his bicycle. When he gets to a corner, he stops to get a drink from his water bottle. At that time, a friend passes by him, traveling at constant speed of 8 meters per second. This is the speed of the friend. Now, after 20 seconds, the boy gets back on his bike and travels with a constant acceleration 2.2 meters per second square. How long does it take for him to catch up with his friend? I insist that is one of the most interesting questions in motion. And if you remember Sultan and Khalid, how we solve for them in their race, we will use the same procedure here. For someone to catch another one, we need to put the position for the first equal the position for the second. That's it. And it's very easy after that. But first, let us decide what is the motion for both of them. For the boy, I'll use the symbol B B means boy, and F for his friend. Now, the situation offered in this question is the friend is with constant velocity. That means the acceleration of the friend is 0. But the boy is accelerated AB with 2.2 meter per second squared. Here is it. Now, the time interval 20 seconds. This is the time needed for the first one to move before the boy. So the time for the boy is the time for his friend minus this amount of time. So the time of the boy equals the time of his friend minus 20 seconds. Now for the displacement, delta x equals v initial t plus 1/2 a t squared. And we know that the displacement is final position minus initial position equals v initial t plus 1/2 a t squared. So the position at any time is the initial position plus v initial t plus 1/2 a t squared. We will consider the initial position is 0, where the boy was stopped before. So put x naught for both of them as 0. Now, for the boy to catch his friend, we need to put x for the boy. The position for the boy is the position for his friend. Now, repeat this equation for both of them. X naught plus v initial t plus 1/2 a t squared for our boy equal x naught plus v initial t plus 1/2 a t squared for his friend. Now let us cancel the zeros. X naught for both of them is 0. The acceleration for the friend is 0. The initial velocity for the boy while he was stopping, it is 0. Now we are left with what? 1/2 the acceleration of the boy time for the boy squared equals v initial for his friend times the time for his friend. Now substitute for the time for the boy by the time of his friend minus 20, or the time of him plus 20 is the time of his friend, which is better. Time of the boy plus 20 equal times time for his friend. So 1/2 a naught time for the boy squared equals v initial for the friend. For time of the friend, it is time of the boy plus 20. Now substitute whatever you can. 1/2 the acceleration of the boy is 2.2, that one. So 2.2 time for him equals the constant velocity for the friend is 8. So the velocity of the friend is 8 times TB plus 20. Now try to simplify. 1/2 times 2.2, it is 1.1 TB squared equals 8 TB plus 8 times 20. So I have 1.1 TB squared minus 8 TB minus 160. 8 times 20, it is 160, equals 0. Use calculator, your calculator with mode 5, 3 to find the time. So TB equals 160, 16 seconds, or minus 8.96. No way for the time to be negative, so we will ignore this solution. So the answer is 16 seconds. So the boy needs 16 seconds to catch his friend. So the time needed is 16. And if you want to find the distance traveled by the boy for that time, delta x equals v initial for the boy t plus 1/2 a t squared for the boy. His initial velocity is 0 times 16 plus 1/2. His acceleration 2.2 and the time is 16. 16 point something, 2, 3, something like that, squared. This was rounded to 2 digits because of the question. Now the distance should be about 290 meters. So he will travel this distance to catch his friend with a time of 16 point something. Okay. Now for part 2, B, if the boy had been on his bike and running along at a speed of 1.2 when his friend passed, what constant acceleration would he need to catch up with his friend in the same amount of time? Now the time is known as 16.2. The initial velocity is 1.2. The acceleration is missing. So we will resolve the question with this or these information. So for part B, x for the boy equal x for his friend. The x for the boy is x naught plus v initial t plus 1/2 a t squared for the boy, and for the friend x naught plus v initial t plus 1/2 a t squared for the friend. Again, the friend has no acceleration and x naught for him is 0. X naught for our boy is 0. Now he has initial velocity. The initial velocity of our boy now is 1.2 as suggested by this question, times that same amount of time, 16.23 plus 1/2. The acceleration now is missing because we need to solve the question at the same time but with different acceleration. V initial for the friend is 8 and the time is 16.23. Solve this easy equation and find the acceleration. The answer is, the acceleration for the boy is 0.838 meter per second square. Don't forget I use the time as 16.23 before rounding. I round it only for 4 significant figures for this branch of question. Now, the last question for goal number 18. A car is moving at 60 km/h, comes to stop in 4 seconds. Assume uniform acceleration. How far does the car travel while stopping? What is the deceleration? I think it's a very easy question. The only problem is to convert the velocity into meter per second. V, initial V equal 60 km/h. It should be 60. The kilometer is 1000 meter, and the 1 hour is 3600 seconds. So the velocity must be 50/3 meter per second. Now it comes to stop, so V final is 0. That was V initial, and this is the time. We need how far, so we need delta x. The most suitable equation is our lovely one, 1/2 V initial plus V final times t. We can use this because the acceleration is constant. That's it. This is the only way to use this equation if the acceleration is constant. 1/2 V initial 50/3 plus 0 V final, then multiply by the time, which is 4. So the answer is 100/3 meters, almost 33.3. What is the deceleration? Now I have V final and V initial. I need the acceleration and I have the time. So 0 equals V initial, it is 50/3 plus the acceleration missing, and the time is 4. Then the acceleration is minus 50/12, which is 25/6. meter per second square, and it is the minus sign because it is deceleration for a positive velocity. Now for goal number 19, we need to study the free falling in vertical direction. First one, if the meter stick falls 0.2 meter, so this is delta y, and since it is falling, so it is a minus. Before you catch it, what is your reaction time? Now the ruler, before the initial velocity for the ruler is 0, and I need to find the reaction time. Now use the equation delta x equals v initial t plus 1/2 a t squared. Convert delta x into delta y, v initial yt. Now the acceleration is minus g times 1/2 t squared. The initial velocity, this ruler is dropped, so the initial velocity is 0. So you can cancel this term. Delta y is minus 0.2 minus 1/2. G is 9.81 or 8 times t squared, and you can easily find t. It is 0.202 seconds. Now this is the same situation as Sultan and Khalid race, and the boy and the friend in this video question. It's the same procedure. The positions are the same. Let us discover that. So it is a very important idea in the exam. Two objects are moving. One of them will catch the other, so they will have the same position. Don't forget that. Even in X direction or Y direction, no problem. Suppose you decide to drop a melon from the first observation platform in Eiffel Tower. So I have dropping, so V initial is 0. And since it is free falling, so A equals minus G. The initial height h from which the melon is released is 58.3, so it is Y initial for the melon. Above the head of your French friend Khalid, who is standing on the ground right below you. At the same instant you release the melon, Khalid shoots an arrow straight up with an initial velocity. This is another initial velocity, but it is for the arrow. It's 25.1. Of course, Khalid makes sure the area around him is cleared and gets out of it. So it's for safety. How long after you drop the melon will the arrow hit it? The arrow meets the melon, so they will have the same position, the same vertical position. And how long means time. Okay. So, like we do with Sultan and Khalid in some previous video, and for the boy and his friend in this video, we will put the position of the melon equal the position of the arrow, and it is a vertical position. Now the position delta y, it is the displacement v initial yt minus 1/2 gt squared. Delta y, it is y minus y naught equal vy v initial yt minus 1/2 gt squared. So y equals y naught plus v initial yt minus 1/2 gt squared. So put this equation for the melon and for the arrow. For the melon, y naught plus v initial yt minus 1/2 gt squared. This is for the melon equals y naught plus v initial yt minus 1/2 gt squared. This one for the arrow. Now let us look up for our zeros. V initial for the melon is 0 because we drop it from above, from the platform. So this is 0. The initial position for the arrow is 0 since it is from down up. This will leave us with y initial for the melon minus 1 g t squared equals v initial for the arrow times t minus 1/2 g t squared. I have two terms equal to each other in either side of the equation, so I can cancel it since they are not 0, so I can cancel them with each other. Now y naught for the melon, it is 58.3 meters. V initial for the arrow, it is 25.1 times t. Very easy question. T equals 58.3 over 25.1. So the time is 2.32 seconds. For part B, at what height above Khalid heads this collision occurs? So use the position for Khalid, for the arrows, I'm sorry. fired by Khalid. Y equals y naught plus v initial yt minus 1/2 g t squared. The first position for the arrow is 0. The initial of the arrow is 25.1. The time is 2:32 minus 1/2 g, it is 9.8. Time, it is 2.32 squared. So the answer is 31.8 or 0.9 meters above the head of Khalid. Now, the other questions for this goal are discussed before. So you can go back to these videos, 266, 267, 268, 269 to discover them. There are 2.60, 2.62, 2.63 to go. Let's go. An object is thrown vertically upward and has a speed of, this is the velocity initial with a positive sign because it is upward. When it reaches 2/3 of its maximum height above the launch point, determine its maximum height. So the speed, this is not the initial speed, it is the speed at 2/3 of its maximum height. So delta y is equal to 2/3 of h, where h is maximum height. Let us picture the question. First of all, this is the launched plane. The object is thrown up by V initial. It goes up, then it reaches a maximum height here. This is the maximum height, and V final here is 0. This is the maximum height, symbolized as capital H. Now we can find the maximum height by this formula, V initial squared over 2g. It is V initial into y, but it is a vertical projectile, so V initial y, it is V initial. So we have 2gh here, 2g capital H equals V initial squared. Let this be the first equation. Now, the question tells me that when it is cover 2/3 of the maximum height somewhere here, this distance is 2/3 of h. The velocity here is 20. So I can make an equation for this V. V final equals V initial on y-axis minus 2g delta y squared. Now V final, it is V, I symbolize it as V. V initial squared, it is V initial, it is vertical, 2g. Delta y is, it is 2/3 capital H. So for this equation, we can use the V squared plus 2 times 2, it is 4 over 3 g h equals v initial squared. This is equation number 2. Now for equation number 1 and 2, we can put like this. This is v initial squared and this is v initial squared. They are equal, so 2gh will equal to this amount. So 2gh equals v squared plus 4 over 3 gh. Now, to solve this equation, two GH give the same minus 4 over 3 GH equals V squared. This 2 can be written as 6 over 3. So 6 over 3 GH minus 4 over 3 GH equals V squared. 6 over 3 GH minus 4 over 3 GH, it is 2 over 3 GH equals V squared. This means that H equals 3 V squared over 2G from this equation. H 3 times V squared divided by 2G. And that's it. Substitute 3, the velocity is 20 squared over 2 times 9.8, and the answer would be 61.2 meter. It's only a skill. How can you form equations, identical equations, and solve them? Okay. Now, on August 1971, astronaut David Scott, while standing on the surface of the moon, dropped 1.3 kilograms hammer and 0.03 kilogram falcon feather from height of, this is the height, it is delta y. Since the objects are going down, so it is negative. Both object hits the moon after, this is the time, delta t, after being released. What is the acceleration due to the gravity of the surface of the moon? It's a very easy question. Delta y equals v initial y t minus 1/2 g t squared. This equation is modifying from delta x equals v initial t plus 1/2 a t squared. Put minus g instead of a and delta y instead of delta x. Now delta y is minus 1.6. V initial is 0 since it is dropped from up. Dropping means V initial equals 0 times t 1.4 minus 1/2 g on the moon. I don't know what is gm times 1.4 squared. Solve for gm and you will get the answer. It is 1.63 meter per second square. An object is thrown vertically and has an upward velocity of 25 when it reaches 1/4 of its maximum height above its launch point. What is the initial launch speed of the object? This question is similar to that one. but in that one we found the maximum height. Now we need to find the initial velocity. I think it's easier than that one. First, draw the question. This is the maximum height, which is capital H. V at the top 0, and here we have the launched velocity VI. 1/4, this is somewhere here. This is 1/4 of H. V equals 25, and here V initial. Now for the maximum height, H equals V initial into Y squared over 2G, but V initial into Y, it is V initial because it is thrown vertically, not with an angle, so I can write V initial squared over 2G. Then this is the maximum height. Now if we apply this equation, V squared equals V initial squared plus 2A delta X into this situation, I will have V squared equal V initial squared plus 2, A it is minus G, and delta X it is 1/4 of H maximum. So V squared equals V initial squared minus 2G times 1/4 H. What is H? H is V initial squared over 2G. So V squared equals V initial squared minus 2G 1/4. Put instead of H, V initial squared over 2G. It is H. You have that. H, okay? Now you can cancel 2G with 2G. Then V squared equals V initial squared minus 1/4 V initial squared. That's it. V initial squared minus 1/4 V initial squared, it is 3/4 V initial squared equals V squared. Then V initial squared equals 4/3 V squared. 4/3 V squared, it is V initial squared. Now solve this equation. V initial equal square root of all. Square root of 4, it is 2. Square root of V squared is V squared V. Square root of 3. Now substitute 2 over square root of 3 times V, it is 25, I think. Yes, it is 25. And this is the answer, 50, I think, over 3 square root of 3, which is 28.9 meter per second upward. See you in last video. Thank you. Have a good time.